I'm not sure if Benjamin wants to come up as well, but feel free
I'll
to.
I'll just say thank you very much um, for uh, wanting to give a presentation. I've been looking for some people to do that, and you were one of the first who agreed to give a little talk. And I'm very much looking forward to hear more about Manim's project structure. Please,
Yep.
Jason.
Thank you. All right, let's begin. So I guess here's how we'll start. We're going to start by looking at the main repository. So let me actually get a browser window open real quick. So Manim community is, not just the main Manim repo, but a bunch of other repos. And for this talk, we're going to be mainly looking at just the Manim public repository and all of its files, starting with all of these files that are at the root of the project structure. So if we open up VS Code and we look through all these files, I mean, for the most part, a lot of these are just configuration files that deal with some aspect of the development environment. So you have things like Flake8 and MyPy and PyLint, which are all doing some sort of linting or like some sort of like style checking, I guess. There's some configuration here for the tests. You have some crowd-in stuff for internationalization. There's a lot of configuration files at the top, but I think probably the most important file is the pyproject.toml or TOML. I'm not exactly sure how you pronounce that, but as Benjamin mentioned in his talk earlier, we have a lot of important things here that go to PyPy, and towards the bottom of the tool is a very important part that has to deal with like the dependencies, the extras, the dev dependencies, and even further down towards the bottom is this very, very important part, which is the Poetry plugins console scripts. These are what kind of designate the main entry point to the Manim project as a whole. So if you look here, you can kind of see that this is saying whenever you type in the Manim command or even the manimce command, it's going to redirect you to this folder here, Manim, on the side, and it's going to take you to the dunder main method, or dunder main module, I should say, and call this main command right here, which is very, very empty if you notice, but there's a lot of other stuff that is happening underneath the hood. We'll get into that in a bit, but I just wanted to like quickly talk about this file just because we have a lot of dependencies here and we're trying to cut down on them in some cases. But the main core package of the Manim project is the Manim subfolder or the submodule. So that is this folder right here. Cool. So that for the most part handles like that's all I want to talk about with like the top level files. There's a couple of like markdown files that are useful for GitHub related stuff, but there's also a .github folder here if you'll notice, and that deals with a lot of things that are related to kind of like development contributing workflows. So you have like the issue templates and the pull request templates. This is what kind of dictate like what's going on when you make a pull request or when you file an issue. And then down here you have the workflows, which is dealing with all the GitHub workflow actions that are happening. So if I pull up a browser window real quick, and we look at Benjamin's recent pull request that he made, and we look at, say, all these checks that are happening, that's kind of what's being asked for in this workflow section. You have all these YAML files that are essentially asking our pull requests to be checked against a lot of these tests. So I don't want to get too much into the continuous integration stuff, but this is essentially what's happening here, and it's also kind of responsible for the general, like, I guess, yeah, continuing integration pipeline. So if you look at all these jobs and stuff, you'll end up seeing like how this all works here, but that's kind of where you would find changes related to continuing integration stuff. Let's move on to the next folder. Here you have a Docker section. So this is a Docker image file, which is very useful for another project within the Manim community. So if you look down towards here, you have Discord Manimator, which is the Manimator bot that we use in the Manim Discord. And it requires the usage of the Docker image file. So if you go to this Docker image file, you can kind of deploy that to like a server or some Docker container and use that to create your own Discord Manimator bot for your own Discord server if you'd like. But that's essentially where that's used. You have the documentation sections in the top level section. So here you have requirements that you should download if you are trying to build the docs. This requires you to use like pip install-r for the requirements here, or you could use the development dependencies that are in the pyproject.toml, so like Sphinx and stuff. But then again, we also have like a read the docs deployment that happens whenever a pull request is made. So if we go to, say, Benjamin's pull request, towards the bottom, there's a read the docs check that happens, and it builds the documentation. That's being held here. And then, of course, there's like some make files. So you have the make files for like Linux and Mac OS, and then you have the make.bat for Windows. I haven't quite used it in a while, but this is what you would use to build the docs at some point, as well as like all the static files that are for the documentation. They're in here in some sense. So like you'd look at like, say, the contributing dot restructured text stuff, and there's like some stuff here, so you can actually like write documentation. But a lot of the documentation, as Benjamin had said, is stored within the actual code itself, or like the doc snippets. So that's all I wanted to talk about for docs. You have example scenes, which if you've used Manim a little bit, you might have referred to these example scenes to like build upon in your own code or your own use cases of Manim. So I won't get into that too much, but they are nice examples. Some of them barren, some of them pretty simple, but they are very useful for getting into the understanding of Manim. We have some logo files, which are, of course, just for appearance or for our servers and stuff. They're used in a couple places around our website and stuff. So, and then we have the main Manim package, which we'll get into in a bit. We have some developer scripts. These are very useful for Benjamin because every time he makes a release, there's a changelog that needs to be generated for letting people know what happened between releases. So the dev changelog is pretty important. It helps give credit and like attributions to who made what PR and like who helped during the release, which is, it's always nice to get credit in an open source project. At least you get like some like bonus internet points kind of for helping out with the project. And of course, there's some other utilities here that are more developer facing, and they shouldn't be necessarily part of the core package or the core library. So that's where these scripts are for. And then lastly, we have like these test cases. So the tests have a lot of control data that goes within the test graphical units here. So in test graphical units within the test folder or test package, there's control data, and this is where you would store all of the like NumPy binary data that is used for comparing the different, I guess, the control data, what you would expect a scene or a piece of Manim code to run and output versus like what you're actually getting. So this is what it's compared to. And of course, there's all the test cases for that, as well as like some other control data. This is like for like video stuff. This tests a lot of like metadata. And we won't really get into testing here because this isn't a testing talk, but this is where all your tests would go. Whether it's related to like the scene rendering or, actual visual output, or in this case, like OpenGL output, it all goes here. And that, for the most part, handles all of the, at a very, very surface level point, it touches on all of the other non-main package folders. So without further ado, let's actually get into the main package. All right, and I'll quickly look at chat because I haven't actually looked at it since the beginning. But if there's any questions about the surface level stuff that I just touched on, yeah, we'll just jump straight in. So actually, before we do that, let me create a terminal. Quickly do a little poetry shell action. So what this will do is create a folder at the top right here, this .vm. It'll create a virtual environment, and it'll indicate that I'm in that virtual environment now. So that's all I'm doing with poetry shell. If I do like a quick little pip list, you'll see that nothing's installed. So we could just do a poetry install to get all the dependencies from the pyproject.toml, and that'll install essentially Manim. If we didn't do that, we wouldn't be able to run the Manim command. And actually, I guess I could do that before this is installed. If I write Manim, it's not installed. But if I go here now, and after installing Manim, I can now write the Manim command, which will give me the terminal output that, I mean, we're hopefully familiar with at this point. You can also do manimce, which is the it's just an alias for the same command. If we look in this pyproject thing at the bottom, you can see the same stuff happens. So I guess, yeah, to start with, let's explore the Manim main command. So if we go into the Manim package and we go to main.py, at the very, very beginning of the entrypoint function into Manim's package, we're importing quite a few things, notably click, cloop, and then a bunch of other smaller subpackages or modules within the main method or the main module. So if we go into these, we can kind of see what like the CLI is doing, what these other packages are referring to. So like here we have some reference to the config package or subpackage. We have some reference to the CLI. You'll see here. And then towards the bottom, we're adding a bunch of commands. There's a lot of commands that we have nowadays, but I think we might be trying to remove some of them. I'm not entirely sure. Check health was added not too long ago, which is convenient. And then the render command is probably the most important of which. It's used to do pretty much all of the rendering for Manim. So if you wanted to add some sort of command to Manim, that would go in the CLI, the command line interface stuff. Within the command line interface, you'll see all of the sub commands that are within Manim. So you have like the check health, the init, the render, and all of the sub commands that are seen here are in the CLI. There's this cool little default group stuff for here that pretty much makes it so that the Manim command gets kind of aliased to Manim render. So there's some magic going on right here to handle that logic, but a lot of the core stuff that we care about with Manim has to do with just the render function of the render command, and that is within commands.py. So in this 150 file or 150 line long file, there's quite a bit of logic that pretty much decides whether you're using the OpenGL renderer or the Cairo renderer, and it also takes in like command line arguments. There's some click arg stuff here. There's some arguments that you can pass into the renderer function. But in addition to the renderer function, there's a lot of logic that happens with this config subpackage or this submodule right here. In the config, or I guess before we get into what this package is, there's a really good article I want to refer to, or really link to, before we get into that. If we look at the Manim documentation, let me grab this. I think I have this. Okay. There we go. I'm put this in the Twitch chat as well for those not on the Discord. But yeah, so Manim has a pretty comprehensive configuration system, which you can read about on our documentation site. But it all kind of goes through this Manim config object within the config subpackage inside of utils. There's digest args, which is primarily for the command line interface stuff, which if you look in the render function, it will deal with the config and digest all of the arguments that are passed through the command line interface. So there's some configuration done here at the render function or at the render command. But there's also some configuration, done with the config files that you're allowed to pass into Manim. So in particular, inside the config subpackage, there's a default.cfg config file, and this has all of the default arguments that are passed into Manim to kind of initialize the Manim config object inside of utils.py. So this is a very important object because it pretty much is like a global variable that allows you to configure the way that Manim functions. And there's multiple ways to modify the state of that Manim config object, which is essentially like a dictionary over a bunch of different arguments or different attributes or parameters. The way that you can touch it is with this digest files. You can digest a config file like the default CFG files, or if you'd like, you could create a new file at the root of your project. So if I look at like, say, one of my projects, this is no longer the Manim project. But if we look at like, say, my workings with Manim, I have like a Manim CFG file that I use, and I can like customize the way that I want Manim to work within just a configuration file. That way I don't have to pass in a bunch of command line arguments every single time. We'll touch on the usage of that a little bit later, but I do want to get back to the project at hand. So within the Manim project, when you run, say, I don't know, if you go to like if I cd into example scenes and I just do like manim.-pql, so we want to preview a scene render at a low quality, we can just give in like basic.py, and it'll ask us to select a scene that we want to actually output, and we'll just, I don't know, at random just do one. Okay, well, that is not something that we should expect. This isn't an error, but we'll do 2. And yeah, so okay, so I'll let that run. What's happening in kind of the the background with that CLI is it's using the default group py to like magically transition Manim to Manim render, and then it's going into commands.py. It's doing all the digestion of config files and command line arguments like the -pql that I gave, and then deciding like, are we using OpenGL or are we using Cairo? And of course, we're using Cairo. Mr. Diver will touch on the case forward dealing with OpenGL, so I'll focus primarily on Cairo for this talk. But in both cases, really, there are very similar instances or like similar logic that's happening with both Cairo and OpenGL. You'll notice something like this: scene equals scene class, and then there's a renderer passed in here because that's the default is Cairo, but in this case, we need to make sure that we're dealing with OpenGL. But in both cases, we initialize a scene that we're given, and then we call scene.render. So what's happening in the Cairo render is the exact same thing. We're initializing the scene that we selected. So in this case, it was opening Manim, I believe, or yeah, opening Manim. And then, of course, it finished rendering. So this is what the output looks like. Does some stuff, and that's kind of cool. Yeah, net outputs it. So in both cases, it creates the scene and then it calls its .render method, and that's not exclusive to just the Cairo render. So let's like up until this point, it's all been I guess library code. And when you're a user of the library, for the most part, you're dealing only with scenes. So if I move this, or I'll just minimize it for now, and I go back to say my project real quick. I mean, every single instance of this is like a scene in some sense. So you have like some scene, or in this case, I might create my own types of scenes. So I might have like, in this case, an audio scene, which inherits from scene and has its own special overrides for specific methods within the scene class. We'll get into that in a little bit. Let me move it to the slide again and go back to the project. So I guess up until that point, we're pretty much running in library code, and then magically, I guess, I shouldn't say magically, but in some way, there is some method here that is dissecting your user code or a user code and reading in the contents of the scene. And we could look into that actually. It's this scene classes from file is essentially returning a bunch of classes to render. Somewhere in here, there's an exec thing that actually reads in the file. I don't know where it is, but without getting too much into the weeds of all the logic that it happens to actually get that, one of these methods within this function actually is responsible for kind of reading in the input or reading in the file. I do not see it, but there's like an import lib or like some usage of import lib, which I guess I could, yeah, right here. Yeah, so you can get the module. I skipped over it, but around here you can actually like exec the module, and it gets all the scenes from a file that the user passes in. You can also pass in like the file, or you can pass in like direct input into Manim through like standard in, but it's not often used that way. There's all sorts of ways you can use scene.render. One of which is through a file, but there are say like in the case of IPython and Jupyter notebooks, I know that there is a way you can use kind of like scene.render from there to render out output onto Jupyter notebooks. So a lot of the core logic is just getting the code and executing it so you can actually use it as a scene object or a scene class. Let me see. Cool. I am not really looking at chat, so I'm sorry if Benjamin, if you could come in and like let me know if there's a question that's been asked that's of a particular interest, I guess. Do let me know.
No worries, I'll take care of that. You just focus on your talk.
Yeah. Cool. So let's see. Some water. So yeah, everything up until this point is just library code. And then at some point we have to like dissect the user code with the scene.render command inside of either one of OpenGL or Cairo. And so there's a lot of stuff that can happen up until that point. But executing the user code is kind of, I don't know, it's in some sense kind of limitless. Like there's a lot of things that users can do with scenes. And so I think the best way to kind of go about this is to kind of maybe take us through an example of what it means to, I guess, render a scene. If we look at a scene object, so like inside of the Manim package, there is a subpackage for scenes. And there's all sorts of types of scenes. There's the moving camera scene, there's the 3D scene, there's the vector space scene, there's zoom scenes, there's all sorts of scenes. I mean, and even in my project, there was an audio scene, if you saw that. So a lot of them, or all of them really, they inherit from this base class of scene. So scene is, I mean, as this documentation describes, a canvas for animations. And there's a lot of setup to scenes. There's the initialization of it when you finally construct it. So like say right here, we have the scene class and we're initializing the scene that the user provided to us. There is some initialization done here. Oops, let me not move that. With like the camera, some randomization stuff, some other attributes that are of particular importance are these moving objects and static objects, which we'll get into much later in this talk. There's some stuff related to OpenGL, like meshes, which don't exist in the Cairo render. You have some DeerPy GUI stuff, which is very particular to this GUI stuff here, which is only for OpenGL, and not well documented at all. But and then like interactivity, which is for OpenGL. And then of course, like towards the bottom of the initialization, there's some render specific logic for OpenGL with the interactivity of mouse stuff, and also down here towards the renderer. But of particular interest to us is this renderer in its scene. So whether you're using OpenGL or Cairo, the renderer is past responsibility of initializing the scene, which is a very, I guess, kind of complex, or it adds complexity to the project unnecessarily. There's a lot of efforts that have been going on to kind of remove this entanglement between scene and the renderer. And I guess I'll quickly mention that here. Within the Manim community project, there's an experimental branch, which, I mean, let me zoom that in, sorry. It's a little hard to see, but you can click on this little like branch stuff and switch between the branches. Mr. Diver and Benjamin, and I'm not sure who else have worked on this branch, but there's quite a bit of work that's been put forth towards refactoring the scene and renderer and kind of disentangling all of the logic that I'm about to explain. So, well, without further ado, let's kind of dive deeper into the complexity that is the renderer and the scene and scene file writer and things like that. But what happens here is that when you initialize a scene, you're really initializing a renderer, and you're also passing into the renderer the initialization of that scene, which is if we go into here, you can see like both OpenGL and Cairo have to init their scenes. We'll focus on the Cairo case here, so let's just click into that and open up the Cairo render. And you can see in this case, all it does is essentially initialize a scene file writer, which at its core is just a wrapper around FFmpeg. And not much more than that. It's kind of our way of dealing with the audio video writing of like partial movie files. So when we look at output, for instance, for here, for this opening Manim example that we ran, there's all this like CLI prompt messages for like partial movie files that are being written. This happens within the scene file writer, as you can see right here on line 527. It's writing some stuff, or that's what it's referring to. But essentially, we're creating partial movie files for each animation. And then at the very end, it's combining all the partial movie files. We'll actually see that in a bit. Let me quickly refer to my notes real quick before I lose myself in the complexity and entanglement that is the rendering logic. Yeah, so here, yeah, we're just initializing the scene file writer and getting FFmpeg access. But there are things beyond that we have to kind of concern ourselves with within scene. And that is primarily that in the init scene, the Cairo render, when we initialize stuff, or I guess really after we've initialized stuff, we still have to go through the scene's logic. And scene has 3 primary methods that are useful for the end user, I guess, which if I click here, you have these 3 functions. So let me minimize this render thing. That we'll get into that later, but there's 3 functions. There's the setup, the teardown, and the construct. The construct is what is mostly used by people. This is where the majority of your animations will be done. But there are useful instances of setup and teardown. For instance, setup can be used when you have scenes that share certain common behaviors. Like maybe you have an audio scene that needs to initialize some, in my case, it has to initialize some audio generators like waves and stuff. So that could be useful there, or like in the teardown, maybe you want the audio to, or the volume to go down to 0 so that it's like a smooth ending to each scene, that you don't have blaring audio just like blasting at the end of a scene. You might want to use setup and teardown in ways like that, but there's definitely other ways to use setup and teardown. But the majority of scenes are going to have a construct, and they're going to have within them some amount of animations or ads. So if we look at examples.py real quick, or the basics.py within the example scenes, we can look at a little bit of example scenes. So like in the opening Manim sequence that we just rendered, you can create a bunch of different, we'll call them mobjects for now, just in general, just mobjects. But then we can also we can write play animations, we can do wait animations, and then I don't see it down here, but you can also do self.ads, which I don't see an example of. Here's an example inside the updaters, where you can just add a mobject directly without actually animating it. And so it just gets added instantly, and is kind of drawn on screen before anything happens, which is quite useful. So there's a lot of different ways you can write scenes, and the methods within them are kind of explained or described within the scene class. There's a lot of methods available, but Some of them are more user-facing than others. You can do like scene.clear, for instance, if you wanted to remove everything and just wipe the clean slate. You don't generally see this in a lot of code, which is, I don't know. Maybe it's not as documented, or I don't know, common to use, but there are definitely a lot of methods within the scene. But the kind of more non-user facing ones are the ones that we're going to concern ourselves right now, because there's a lot that can happen here. So within the I guess construction of a scene, I mean, right here we just pass it, but normally we would kind of overwrite that within our scenes and then do some logic involving objects. So that kind of begs the question, like, what is a mobject? Like, what are we animating? And at its core, mobject, and really OpenGL objects too, are things that we want to draw on screen. And mobjects are a kind of abstract interface, I guess, over things that should be drawable. And the important bits of a mobject are its sub-mobjects, which are itself mobjects, and kind of this attribute called points. Anything that has points can be drawn, essentially. And within mobject itself, there's three different types of mobjects. I guess the biggest and the most important one is vectorized mobject, so vmobject. But then there's also image mobject, which is useful in both. Well, more so, it's useful in the Kyle render. In the OpenGL render, it's a little bit buggy, but these are ways you could draw images on screen, so like a PNG file or something like that. And then point cloud mobject, I haven't personally really seen used much, and I've never quite used it myself much, but I don't know if it could be deprecated. It's just kind of like a pixel mobject, I guess. It's very very niche, I guess. But there is some documentation for it, but theme object, so like it's very small, like pixel dots objects. I don't know if it can be incorporated within vectorized object in the future, but for the most part, when we're looking at objects, we're concerned with vectorized objects or vim objects, and we're really concerned with the points array or the points attribute. If you look at the initialization of a object, there are a couple of attributes here that are used, primarily, like, I guess we're concerned with sub objects and then the points array. But there are some other attributes here that are useful or are kind of used within the logic to like draw stuff on screen, like the dimensions of the object. So whether we're working in like 2D or 3D. But every single object is running through these three methods in some way to kind of alter the points attribute or the points array. So if you look at reset points, all it does is kind of makes a zero vector of all the points. So that makes sense because this is an abstract object, and generally you don't want things to be drawable for just abstract stuff. So we just kind of wipe it to a clean slate. And then for vectorized object and for pm object and for image object, they have to generate their points. So we just kind of call pass. We don't want to alter the points array, and we leave it to the responsibility of other the things that inherit from object to generate those points. And then lastly, we do some color initialization, which we'll get into. So I don't know, just to kind of quickly involve the chat, is there any specific vectorized object that you guys find interesting or use quite often, or are I guess have used recently and then would like to see how it works? Because I think there's quite a few possibilities to go through, like how points are generated on the screen, but I would like to get a user example if possible. Maybe something like square, circle, or like a line, or I don't know, a number line, axes. I think drawing something on screen is once you kind of know how it works for one object or one vectorized object, you kind of know how it works for most of them. But transform matching tech, latex objects. Okay, those are a little bit more complex in how the generate points are initialized, or how the points array is constructed, I guess, or created. But we can certainly take a look at it. So single tech thing, class single. So when you use like math tech, for instance, it inherits from the single string math tech, and it kind of composites all the latex strings. So somewhere in here, there's going to be some override of, or there should be an override of generate points. It might not happen here. It might happen at a higher level. Sheesh. Let's go down the inheritance line. If you look at SVG object, it's doesn't always happen. Sometimes there are some inconsistencies in the library where like sometimes it doesn't use the mobject generate points to actually construct the points array as you would expect. So if we go to class mobject, we kind of expect every single vectorized object to kind of run or override these two things. So if we look at generate points, we would like to see a generate points in single string math tech or SVG object. Doesn't always happen that way. The generate points, but see if I can find it real quick. So here we kind of assign generate points to init points. So we're using init points to actually initialize the points, and then we're using set points to actually set the points. So somewhere in this logic for get points without null curves and subdivide sharp curves, there's some logic that's handling the initialization of an SVG image. There's a lot of commands that are used within an SVG object, or like an SVG in general. SVGs are kind of I don't know, structural in a sense that they have different types of curves available to them. They have like simple curves that are like circles and rectangles and stuff like that, but they also have like cubic Bezier curves and quadratic ones as well. And having to have logic within Manim to kind of adjust or address the cubic case or the quadratic case is kind of an ongoing I don't want to say issue, but it's an ongoing effort that we're addressing. So at some point you're able to like, there's this points attribute right here, this points array, and it's kind of dealing with all the logic that you would want to draw these cubic Bezier curves that Manim uses. So at its core, like all we're doing to draw objects or draw vectorized objects is we're addressing the points array, which is usually an NP array. Let me get a bit of water. Or quadratics in the case of OpenGL, yeah. So I don't want to get too much into the logic of how SVG handling works, because that's a little bit more of an advanced case of handling the points array. If you look at other cases of vectorized objects, like if you look at square or circle or like line, they are a little bit more simpler to grasp kind of the ideas of how they're setting the points array. But that's what's happening at its core. We're just concerned with the points array to draw Bezier curves. So LaTeX is an SVG. LaTeX is there's like a LaTeX engine, and it writes tech files to, I believe, DVI and then SVG. Yeah, Benjamin, as Benjamin says, yeah, it's we're essentially pulling the SVG file from whatever LaTeX engine you use to kind of parse all of the SVG commands that are given, and that's what happens underneath the hood without getting too much into the weeds of that. But let me get my notes again. I think I kind of went off a little bit of the rails, but yeah, I mean, when we're looking at example scenes, which I lost the file for that, let me get an example scene real quick. So we go back to basics.py. You have all these instances of scene where like we're doing scene.add or scene.play or scene wait. So these are all the different or common ways that we can kind of write animations. And so it's kind of important that we understand what scene.add does, scene.play does, scene.wait does. And of course, these are the ones that kind of animate stuff. These are the ones that just kind of add stuff instantaneously in a or at a single moment, and then just kind of pop things up on screen. So if we look at scene.add, which we can do here, if we scroll down to add, we are again asking ourselves, are we using OpenGL or are we using Cairo? It's a very common theme when you have two renderers. There's a lot of logic like this that you'll see in the code base with config.render equals, or you might even see it like config dot, or not even dot, just renderer like that. So be on the lookout for things like that, just to know like when things are kind of renderer dependent. But what we care about in the context of Cairo is kind of the mobjects array, which for the most part, yeah, all we care about is just this mobject attribute, and the ordering within that array means kind of the order within which things are drawn on screen. So if you have like I don't know, let's say like object one, object two, dot dot dot. Object one is going to be drawn first on screen, and then object two is going to be drawn usually later on screen on top of object one. So you might have like this idea of like z-index, which is useful for kind of structuring objects in the correct order and the correct draw order. If you look at, if we go back to mobject, sorry, we're bouncing all over the place, and hopefully I'm not losing people, but there is this idea of a z-index within the mobject class, and that helps kind of like keep, at least in the Cairo engine, Cairo render, it keeps things kind of in the correct order as you wish them to appear. Correct draw order. So yeah, generally, yeah, we care about just the self.mobjects array, and there's this idea of restructure objects, which is a little complex in how it, I guess, moves objects and keeps their ordering, I guess. Like, I'm not too familiar with how it works, but I mean, it's, I know that it's you kind of used to kind of remove a object and then place it higher up in the structure tree to kind of like flatten the objects array. But generally, it's kind of keeping the ordering of objects when the animations are happening within the scene. So let's go into scene.play. play, I guess. Let's see. We're in scene. I don't want to save that, I guess. So in scene, we can also go to where's add? There's add. There's also play. So play is usually what we use when we want to ask for things to be animated. Wait is also another instance of when we want things to be animated, but usually it's kind of like a freeze frame condition where we don't really want anything to happen. Of course, that self.wait is essentially just another way of calling self.play with a wait animation. So they're, in essence, kind of the, I don't know, just like a quick shortcut to this. And of course, self.wait doesn't necessarily mean nothing is being animated. It just means that we're using a wait. We kind of course, use like updaters, which are a concept within Manim that allow us to animate things using just usually like time or some sort of mobject. So yeah, just because we're using self.wait doesn't necessarily mean that nothing is being moved on screen. There are conditions and logics that we have to pay attention to within the play method, which are important for determining whether things are being animated or not. So if we look at self.play, we have an instance where, again, we're passing kind of the logic back to the renderer, passing to the renderer, which is like an unfavorable way to handle, I guess, the logic of, or like the entanglement of logic between the renderer and scene. There's definitely stuff that has to be addressed here and might have already been addressed. I haven't really quite looked at the work that Mr. Driver and Benjamin have done in the experimental branch, but perhaps that's something for a future talk somebody will give. So we'll have to look at that at some point, but there is some play here with the renderer, and we're passing logic to the renderer, and here there again we have the Cairo renderer play, and then we have the OpenGL renderer play. In the Cairo renderer play, we have some logic handling whether like animation should be skipped or not, or like whether updating should be skipped, and then this is kind of like based on some flags that we could pass or some configuration, like the Manim config dictionary that we mentioned in the very beginning. It might have some sort of attribute or parameter within the dictionary that tells us to like not render the entire thing to completion. It might tell us to skip animations or to like play the last frame. Those are all things that can happen. And then within the Cairo renderer's play, we're asking the scene to compile some animation data, which in doing so, like if we look at compile animation, compile, I can't spell, compile animation data. So we're getting all the animations and then using this to kind of get some runtime stuff. We're also getting just in general, like what the moving objects are and the static objects are. We go back to the renderer. Let me refer to my notes so I don't get too lost, because this does get quite complex, the way that the renderer switches logic between plays and whatnot. So when we go to the renderer and we ask ourselves to play stuff, the thing that I want to address most commonly, besides like here we have like some skipping stuff, we have some caching logic that happens here in the renderer's play, which we won't really touch on the hashing or the caching logic of Manim, but what is important and what happens in each instance of rendering a scene when you call scene.render is we have to kind of open up the ffmpeg pipe with the scene file writer. So that's where this stuff happens in the file writer. We start to begin the animations, open up the pipe for a partial movie file or for it to be written. And then we ask the scene to start begin animations. So if we go to scene, there's a lot of like bouncing back and forth between the render and scene in this play, which is something that needs to be fixed. But in the begin animations here, it's essentially just initializing the animations, and it's doing like a begin in the same way that a scene has like a setup, construct, and teardown. An animation, which we'll look at right now. An animation has something very similar, and then it has like a begin, an interpolate, and a finish, which I'll show here. So in the animation class, we have the begin, which uses the interpolate function at time equals 0, and then the finish does the same thing, but it interpolates at time equals 1. And then the interpolate function itself is essentially like an alpha parameter. It can take values between 0 and 1, and what we're doing with animations like, say, transform or create or things like that of that nature is we're interpolating between the mobject's start and endpoints. It's very important that we look at the, I guess, constructor of an animation, because it gives you kind of an idea of what animations are. Animations, if we minimize that and the new, look at the init, every animation is kind of acting on top of a mobject. Of course, there's other attributes or parameters you can pass into an animation, like a lag ratio. There's runtimes, which, even though the interpolate function works between 0 and 1, that is kind of like layered on top of the runtime. So if the runtime is 5 seconds, 0 would represent 0 seconds, and 1 would represent 5 seconds, and you're kind of interpolating between those time periods with the alpha parameter of interpolate. So that's what this thing is doing. It's just interpolating between the runtime, I guess, in essence. But yeah, within the initialization of an animation, we're acting on objects, and that helps because it lets us know what is the what the starting object is and how we should go about interpolating between the start object and then the points in between the start and the end. So if we go to an animations interpolate, of course, we could think of acting on top of mobjects in the interpolate or in the animation, but we can also interpolate on the submobjects. We can interpolate on the whole group of mobjects within an animation. So I think it's helpful if we look at an example. Let's see. So then let me see. Within the begin animations of scene. So we begin a scene, or we begin an animation within begin animations of scene, and here we're able to see like what is moving and what is static. This is important so that when we create these moving objects and these static objects, which are later on kind of used for the self.mobjects attribute, we can determine which mobjects are drawn on top of the screen last. So let's see. Let's get back into the renderer, or not the renderer, the scenes play real quick. Let's jump back. Where is play? Play. Okay. So geez, there's a lot of confusing. It keeps bringing me back to OpenGL. Okay, so scene.play calls renderer.play, and then there's some animations that are compiled and stuff is done there to kind of open up the FFmpeg pipe. We go into the beginning of animations, and then let's just suffice it to say that there are there's some extra logic here that handles like whether things should be frozen in frame and done here, but a lot of the logic happens at the end of the renderer's play, which is this scene.play internal. Scene.play internal is kind of what's handling the I guess the interpolation of objects. It's kind of at its core, I think a lot of the handling of drawing happens here. So let me go into play internal if I can find that real quick. Just to give a really brief touch up on what's happening here, but it's using kind of the animation objects that we have referred to when we're beginning them, and then it's doing some update to time. So this is what kind of allows us to, oh, let me not shift that, but update the time. It allows us to kind of use the time parameter to kind of pass into the animations and update them. So it's like doing the interpolation of the animations within Play Internal. And after it's done kind of interpolating all of the animations and like where the mobjects and the corresponding moving and static mobjects should be there, it's Play Internal asks the renderer, which in this case is Cairo, it asks the renderer to do some rendering, which the renderer's rendering is just like a simple get the frame and then add the frame. So this is I mean, it's not really, it doesn't necessarily need a comment, but the update frame is just getting all of the stuff on screen and capturing it with the camera. And then after updating the frame and getting all the corresponding like numpy array pixel data for the camera, it just adds that to a frame. And this is like the scene file writer or the FFmpeg pipe, kind of like concatenating image frames to the video file stream over and over and over and over throughout the course of Play Internal's animation. So there's a lot of for T and self-time progression, there's a lot of time steps happening. It depends on your frames per second that you chose in the Manim config object, but there's pretty much here in this thing, there's a frame being generated or a frame being captured by the camera. And then it's just being written to the scene file writer through the FFmpeg pipe. After which, when we're done with that specific animation in the self.play or the self.wait, we ask the animation to do its cleanup and its finish. And there's some last bits of like cleanup that are done with like the TQDM pipeline. So like the if you look at right here, or actually I have to run it, but if you run this again, this is the TQDM thing that I'm talking about. Oh, you can't even see it because it's let me add another disable caching. So if I do 2 again, you can kind of see like there's this well, geez, it's really hard to see, but if I can get like a, I guess I can't really grab a time snippet, but if you get longer complex animations, you'll usually see like a progress bar. So that's kind of what's happening here towards the towards this time progression dot close right here. It's just cleaning up the progress bar. And that more or less is how the Cairo renderer works without getting too hairy. Sorry if I've gone overboard with the time here, but
you're lucky. I just wanted to say something.
Yeah, that is more or less how animating works with render. Yeah. Uh, I hopefully there's not too many questions. I don't know how much time we want to go over, but
Well, thank you very much. First of all, this was a pretty impressive walk through the rendering pipeline. Basically, it's a really very dense thing, and I think initially I went through the entire thing at some point. It has been like some months ago, and the entire video where I did that, it's on YouTube, by the way. But it takes like I think 3 hours or something like that. So I'm very very impressed that you managed to boil it down to say, I don't know, maybe half an hour, maybe
hour.
something like that. So pretty cool.
Yeah, I think I'm a little or maybe like 15 minutes, 15 to 30 minutes over. So, if there's not too many questions, I'll hop back into the audience. But yeah, I'll leave the floor open right now for a few quick questions. I
Yes,
was not paying attention to questions, but
no worries, no
or
worries.
like
So
the chat too much.
I think it makes sense. If there are any questions right now, we can still address them. Otherwise, let's take like because it was very very dense, and I also need more coffee or at least water. So let's take maybe a 10-minute break and then continue with Mr. Diver's talk if that's okay for Mr. Diver too.
Yep.
Should be fine, I think.
Should be fine.
Yeah.
Excellent. Okay. It does not seem like there are any questions right now, but maybe we'll come back to rendering in the Q&A part. There was actually one question that I already delayed to later by Fuzzy Penguin about the skipping, which we can talk about after Mr. Albert was talking in the Q&A. Maybe that's a good idea.
I had just noticed the chat. Yeah, maybe like 10-ish more minutes. Definitely lost in the render.
That does tend to happen sometimes.
It is
Okay.
a complex object. But
yeah, definitely. The render really is very, very complex. So let's take like 10 minutes and see you then for the next talk. I'll move down to the community meeting room again, but I will get some coffee too. Be right back.
sounds good.